Subliminal activation of stress response is one of the most important effects of EMF and non-ionizing radiation have upon life, but it's far from the only one. These unfamiliar energies produce changes in nearly every bodily function so far studied. Many of these alterations are associated with stress, but whether they're a result of or an additional trigger for the adrenal cortical reaction is an irrelevant chicken or egg question at this stage of our knowledge. The most disturbing data come from work on the systems that integrate other bodily functions, the central nervous system, cardiovascular, endocrine, and growth control systems. We'll concentrate upon these in the following overview of biohazards. For the most part, no attempt will be made to identify specific effects from microwaves, radio waves, and electric or magnetic fields where similar changes have been observed from all modalities. The major problems from the extremely low frequencies, but higher frequencies have the same effects if pulsed or modulated in the ELF range. This is very often the case to transmit information. Microwaves or radio waves must be shaped. This is done by interrupting the beam to form pulses or by modulating the frequency or amplitude size of the waves. Furthermore, today's environment is a lattice work of crisscrossing signals in which there's always a possibility of synergistic effects or the construction of new ELF signals from the patterns of interference between two higher frequencies. Therefore, experiments in which cells or organisms are exposed to a single unmodulated frequency, though sometimes useful, are irrelevant outside the lab. They're most often done by researchers whose only goal is to be able to say, see, there's no cause for alarm. Since our work on human reaction time, half a dozen other groups have found marked CNS effects from ELF fields. Most experiments have shown a decrease in reaction speed, although one researcher noted faster than normal reactions in humans exposed to very weak electric fields, vibrating at beta wave frequencies. The sensitivity of some animals has turned out to be amazing. James R. Hammer of Ross Eddy's group at UCLA reported changes in monkeys' response times from ELF electric fields as weak as 0.0035 volts per centimeter, roughly equivalent to the field from a color TV set 60 feet away. One of the most telling tests was a simple one done at the Navy's Pensacola lab. R.S. Gibson and W.F. Moroni measured people's short-term memory and their ability to add sets of 5 two-digit numbers in the presence of a 1 Gauss magnetic field. The strength found near some high voltage power lines and many common high current appliances such as portable electric heaters. Test scores declined at both the 60 Hz power frequency and the 45 Hz frequency of the sanguine seafarer antenna, but remained normal in control sessions. Several studies on both sides of the Iron Curtain have found that rats are generally less active and less exploratory of their environment after being dosed with microwaves, although some frequencies induced restlessness. In contrast, ELF magnetic and electric fields almost always produce hyperactivity and disturbed sleep patterns in rats. Obviously, the subtle workings of the mind may undergo many shifts that don't show up in these crude behavioral tests. Most of our knowledge of pollution's effects on the brain concerns variables that can be more easily quantified, such as changes in biochemistry, cells, and EEG patterns. These studies can't be easily related to changes in thought processes, but most of the results fit in well with the stress response. In 1966, Yuri Kolodov found effects on rabbits' EEGs from a few minutes exposure to fairly strong steady-state magnetic fields, 200 to 1,000 Gauss. As we'd found in salamanders, there were more delta waves as well as bursts of alpha waves. He and another Russian biophysicist, R.A. Chizhenkova, also noted a desynchronization or abrupt shift in the main EEG rhythm for a few seconds when any field was switched on or off. The same effect has since been confirmed in rats with microwaves. This proved that the brain could sense the field, whether animals knew it or not. The site of the greatest changes, the brain's hypothalamus and cortex, were cause for concern. The hypothalamus, a nexus of fibers linking the emotional centers, the pituitary gland, the pleasure center, and the automatic nervous system, is the single most important part of the brain for homeostasis and is a crucial link in the stress response. Any interference with cortical activity, of course, would disrupt logical and associational thought. In 1973, Zenaida V. Gordon, a pioneer in microwave research, working with M.S. Tolgoskaya at USSR Academy of Medical Scientists Institute of Labor Hygiene and Occupational Diseases, reported a possible cellular feature of EMR stress. Low doses of microwaves, a mere 60 to 320 watts for an hour a day, changed nerve cells in hypothalamy of rats. During the first month of exposure, the neurotransmitting secreting portions of the cells connecting the brain to the pituitary gland were enlarged. After 5 months, they'd begun to atrophy. When microwave dosage was stopped at that point, however, the cells recovered J.J. Noble's findings that ELF electric fields changed brainstem acetylcholine levels has already been mentioned. In similar experiments, others have noted a rise followed by a drop to below normal in rat brain levels of norepinephrine, the main neurotransmitter of the hypothalamus and automatic nervous system. In Soviet work, microwave densities of 500 microwatts or more delivered in a work exposure pattern of 7 hours a day gradually reduced norepinephrine and dopamine, another neurotransmitter, to brain levels that indicated exhaustion of the adrenal cortex and atomic system. 2 years after the Gordon-Togoskaya report, Alan Frey, who has studied bioeffects of microwaves for over 2 decades at Random Line, Inc., a consulting firm in Huntington Valley, Pennsylvania, found an effect on the blood-brain barrier and cellular gateway by which specialized capillaries strictly limit the molecules admitted to the delicate nerve cells environment. Even at power densities as low as 30 microwatts, microwaves pulsed at extremely low frequencies loosen this control, in effect opening up leaks in the barrier, since some of the barrier changes occur in response to stress and mood shifts. This could be either a cause or a result of the stress response, or an unrelated effect of pulsed microwaves. In any case, since the blood-brain barrier is the central nervous system's last and most crucial defense against toxins, we must consider this increased permeability in grave hazard until proven otherwise. Researchers have noted several other potentially dangerous direct effects of the electromagnetic smog on the neurons. In 1980, a group under R.A. Haffey at Pacific Northwest Laboratories in Richland, Washington, found a general increase in neural excitability, especially at the synapses, in rats exposure to 60 Hz electric fields of only 10 volts per centimeter for 1 month. That same year, A.P. Sanders and co-workers at the Duke University Medical Center in Durham, North Carolina, reported as follows on biochemical tests of rat brains subjected to microwaves at 2 levels, 1/2 and also slightly more than the U.S. safety standard of 10,000 microwatts. The results suggested that microwave exposure inhibits electron transport chain function in brain mitochondria and results in decreased energy levels in the brain. In a series of experiments spanning more than a decade, a group of scientists headed by Ross Adey, first at UCLA and later at the Loma Linda VA Hospital, have studied neuron response to ELF fields and pulses. Proceeding from Hamer's work on reaction time, they first ascertained that even weaker electric field, roughly the influence of a light bulb 10 feet away, changed the firing rate of brain cells in monkeys and humans in the field was pulsing at brain rate. if the field was pulsing at brainwave frequencies. Then, working with radio waves beamed at chick brains kept alive in culture dishes, they found specific pulse rates that decreased or increased the bindings of calcium ions to the nerve cells. The flow of calcium ions in and out of the neurons controlled the firing rate of impulses in a complex feedback system. Two windows of pulsed radio waves, 147 megahertz pulsed at 6 to 10 hertz, and 450 megahertz pulsed at 16 hertz, increase the flow of calcium from the cells, interfering with impulse transmission. Unfortunately, for conceptual simplicity, but fortunately for the rest of animals and the rest of us, the pulse frequencies that worked on isolated brains don't work on whole animals. Adie has publicly expressed his conviction that pulses for changing calcium flow in intact nervous systems do not exist. However, he expects that a calcium efflux would interfere with concentration on complex tasks, disrupt sleep patterns, and change brain function in other ways that can't be predicted yet. This research obviously points towards confusion beam weaponry. So effective windows may already have been found, but they haven't been reported in the open literature. Be that as it may, Eddy's work remains an important clue to the interaction between EMR and the human CNS at the brain's most sensitive frequencies. Together with the other findings just mentioned, it shows that electropollution can trigger profound and dangerous changes, even if we don't know yet exactly how and when. Just how dangerous these changes may be was indicated by a study that Maria Reichmanis, Andy Marino, and I did in 1979, collaborating with F. Stephen Perry, a doctor near the town of Wolverhampton in Western England. Perry had noticed that people living near overhead high voltages seemed more prone to depression than others in his practice. Since electric fields changed norepinephrine levels in rat brains, and since depletion of this neurotransmitter in certain brain areas was a clinical sign of depression, the connection seemed plausible. We knew from earlier work that although electromagnetic field strength fell off quickly in the immediate vicinity of a power line, the rate of decrease lessened with distance so that the field was often well above background levels over a mile away. Reasoning that suicide was one unequivocal and measurable sign of extreme depression, we plotted the address of 598 suicides on maps, showing the location of power lines in Perry's locality. Then we statistically compared this distribution of set of addresses chosen at random. The suicide addresses were, on the average, closer to the high voltage wires. We found the same association with underground power lines, but we couldn't be sure whether more than the statistically expected number of suicides had occurred in areas where the fields were strongest. Since the total field strength was a combination of elements from many sources, we proceeded to measure the actual levels. This confirmed a link. Magnetic fields averaged 22% higher at suicide addresses than at the controls, and areas with the strongest fields contained 40% more fatal locations than randomly selected houses. The endocrine, metabolic, and cardiovascular systems. Living things interpret electromagnetic energy for information about time and place, so they must have a means to filter out useless signals, although perhaps not those never before encountered. Many studies have found that the bioeffects of artificial energy stabilize after a few weeks, suggesting that animals adapt so as to live normally in the changed environment. Hence, there's a large body of work that's often quoted to prove that electropollution isn't dangerous. As already noted, this simplistic viewpoint doesn't take into account the additive effects of stress. Moreover, when a stress is too strong or too persistent, compensation fails, and the effects become obvious and sometimes irreversible. When evaluating research on hazards, therefore, we must always ask whether the experiment was continued long enough to be informative. Otherwise, a short-term study showing harm is likely to be truer than a reassuring one of medium length. The primary effect of electromagnetic energy on the endocrine system appears to be the stress responses already described. The major confirmatory study in humans comes from the Soviet Union, where detailed medical tests of 72 technicians exposed daily to 1,000 microwatts or less disclosed ominous changes in white and red blood cell counts and an across-the-board decline in immune response. The workers and a group of controls were studied for 3 years. No human study approaching this in length or completeness has ever been done in the West. The only other consistently noted glandular change in the thyroid. The work of several Soviet groups and one American team in the 1970s has clearly shown that radio and microwave frequencies at power densities well below the American safety guideline of 10,000 microwatts stimulate the thyroid gland and thus increase the basal metabolic rate. L fields at 50 Hz, on the other hand, have depressed thyroid activity in several experiments on rats. It isn't yet known whether this is a direct effect on the thyroid or whether, like the stress response, is at least partly caused by alteration in brain function. One more link in the bioclock interference and stress response has come from the 1980 work at Battelle Pacific Northwest Laboratory in Richland, Washington. Working with rats, researchers there found that a weak 60 Hz electric field, only 3.9 volts per centimeter, canceled the normal nightly rise in production of the pineal gland hormone, melatonin, the main hormonal mediator of biocycles. The cardiovascular system responds to electromagnetic energy at least 2 ways. The composition of the blood reflects the stress response and concomitant activation of the immune system, while frequencies exert a direct effect on the electrical system of the heart. Soviet scientists have observed a variety of blood changes in animals exposed to microwaves, radio waves, and L fields. These include declines in red blood cell count and hemoglobin concentrate, and hence oxygen capacity, as well as changes in the relative numbers of various types of white blood cells and the relative amounts of blood proteins, and a possible reduction in the blood's ability to clot. Most of the discomforting studies of electropollution have been done by the Soviets, and they've been given short shrift by Western scientists. There are many reasons for this attitude. There's a simple prejudice against all things Russian and feeling that their science, technologically less flashy than ours, is necessarily cruder. Western researchers have hamstrung themselves with the dogma that there simply can't be bioeffects from low levels of electromagnetic energy, so why bother looking? Then, too, Russian publication standards are different. Procedural details are often admitted, making replication difficult. In addition, there are often troubling contradictions in the data themselves. Results are often inconsistent from animal to animal. If red blood cell count goes up in one, it will go down in another. So the experiment shows no statistical change, even though every animal blood composition is going haywire. In such situation, the ultra-mechanistic Americans tend to believe the statistics, while the Soviet biologists concentrate on the animals. Russian scientists have been systematically studying electromagnetic bioeffects since 1933, and we can hardly afford to dismiss their entire body of work simply because it comes from a country we fear. My associates and I therefore proceeded from one of the most detailed Soviet reports and design an experiment to measure effects on the blood of mice as our test fields were turned off and on. We concluded that these effects weren't a reaction to the fields themselves, but rather a transient compensation that the animals were making in response to any change in their electromagnetic environment themselves. None of the blood fluctuations were especially hazardous. However, since we all live amid EMFs that are constantly shifting as we turn appliances on and off or travel from place to place, the continual blood instability could be significant. American attitudes began to alter in 1978 to 79 when Richard Lovely of the University of Washington took advantage of a determined, inspired exchange of microwave results to visit the Soviet Union for a month and study Eastern methods closely. His research group then painstakingly recreated a major Soviet experiment in which rats had been irradiated 7 hours a day for 3 months with 500 microwatts. The Russian work was confirmed in every detail, including disruption of the blood's sodium-potassium balance, other than pathological changes in the blood chemistry, damage to the adrenal glands from stress-induced hormonal changes, diminished sense of touch, a decline in explorativeness, and slower learning of conditioned responses. Donald I. McCree, director of the EPA Electromagnetic Radiation Health Research Program, termed the results very interesting and called for an end to the American establishment's contempt for Soviet work. Electromagnetic energy has other adverse effects on blood composition and tissue function. Yuri D. Dumansky, one of the many Soviet biophysicists who have done detailed work on microwave hazards, found changes in carbohydrate metabolism, including a rise in human blood sugar levels resulting from 100 and 1000 microwatts. Power frequency 50 Hz fields were also linked to altered sugar and protein metabolism in rats, as well as decreased muscular strength in rabbits. Like many other Russian results, these were questioned because of American failure to corroborate them. In this case, a research team headed by N.S. Matheson of the Armed Forces Radiobiology Research Institute in Bethesda, Maryland, reported no such metabolic changes in response to sanguine seafarer 45 Hz frequency. However, the Matheson group made a fundamental mistake. They neglected the account for the 60 Hz background field near the test cages in their lab. Even though they'd measured it when setting up the workstation, when we realized their data in light of this omission, the experiment showed exactly the same changes in blood levels of glucose, globulins, lipids, and triglycerides as the Russians had found. The most frightening data so far on blood composition came from a preliminary study for Project Sanguine. Dietrich Bischer found that one day of exposure to a magnetic field, such as would be produced by the ELF antenna, caused a 50% rise in triglycerides in 9 of 10 human subjects. The NOS committee's conclusion that this early result didn't stand up was based on the subsequent Navy work, mainly the faulty Matheson study. Adequate follow-up by a disinterested group has never been funded. Even though Bischer's finding agrees completely with Russian studies and the reinterpreted Matheson data on animals, this doesn't exhaust the list of microwave metabolic effects reported behind the Iron Curtain. Dumansky found widespread changes in the liver function of rats exposed to low levels of microwaves that were scheduled to approximate the pattern of mealtime exposure from microwave ovens. Others detected vitamin B2, B6 depletion from blood, brain, liver, kidneys, and heart, as well as major shifts in trace mineral metabolism in response to low levels of microwaves. The distribution of copper, manganese, molybdenum, nickel, and iron was affected throughout the bodies of rats. Similar trace metal changes were recorded after exposure to electric fields for 4 months, even though at moderate field strengths for only half an hour per day. Since B6 is essential to the utilization of carbohydrates, fat, and protein, and since the trace metals act as catalysts in a wide variety of biochemical reactions, these observations may explain some of the other metabolic changes. There are indications that some types of electropollution directly decrease the efficiency of the heart. Several research groups in Poland, the Soviet Union, Italy, and the United States have studied pulse, electrocardiogram, blood pressure, and reserve capacity, heart's ability to handle exertion in animals. Microwaves and 50 hertz electric fields both produce similar changes that persisted throughout long-term exposure. These included bradycardia, decreased pulse, a huge reduction, 40 to 50% in the strength of electro impulses governing contraction of the heart muscle, a decline in reserve capacity, and the short-term rise following a long-term fall in blood pressure. In general, these decrements occurred in both domestic and industrial 50 volts per centimeter or more electric fields, and at microwave power densities of 150 microwatts, well within the amount received by many people from radar beams and microwave ovens. In humans, confirmatory evidence for these effects comes from several Russian studies of workers in high voltage power station switchyards. In the first such group examined, 41 of 45 had some sign of nervous or cardiovascular disease, including bradycardia, instability of pulse and blood pressure, and tremors. The same health problems were found in 4 additional studies of nearly 700 more workers. The only comparable American study is much quoted for its failure to find consistent health damage in mere 11 power line maintenance workers, growth systems, and immune response. Given the results presented so far and the dynamics of life's connection to the Earth's field, we can now make several predictions about the effects of ELF pollution. The most important aspects of the natural electromagnetic field of 4 biological timing systems are the lunar circadian rhythm and the micropulsations of 0.1 to 35 hertz. It seems logical that cells will perceive frequencies close to normal more readily than those further removed from the norm. Therefore, we can postulate that the ELF band from 35 to 100 hertz would be the most damaging, while higher frequencies might go more or less unnoticed until the energy injected into cells became intense or prolonged enough to be significant. The accumulating evidence supports this idea. Based on this notion, we can predict 2 major ELF effects that would encompass many others. We can expect the abnormal signals to disrupt biocycles. Such disruption would trigger the generalized stress response even if the EMR induced changes in brain neurotransmitters were only an effect and not a cause of the stress reaction. In addition, the wrong timing signals would likely throw off the mitotic cycle of time of every cell, interfering with the growth processes throughout the body. Although any number of factors can trigger the adrenal cortical stress reaction, the response itself is always the same. It involves the release from adrenal glands of specific hormones, mainly the corticosteroids, which in turn mobilizes body against invading germs or foreign proteins. Thus, the stress response always activates the immune system. Short exposures to stress aren't necessarily harmful and may even be healthy. In fact, the Soviet work on microwave stress has disclosed a brief period of increased immune system competence at very low intensities, under 10 microwatts. However, when an organism must face a continual or repeated stress, the response system enters the chronic phase, during which resistance declines below normal and eventually becomes exhausted. Several well-known diseases, such as peptic ulcer and hypertension, result directly from this stage, but the most important result in a decrease in the body's ability to fight infection and cancer. The trouble is that the immune system is geared to fight intangible invaders, bacteria, viruses, toxins, and misbehaving cells of the body itself, or such consciously undetectable stresses as heat, cold, or injury. It includes a system of circulating antibodies by which specialized cells recognize the intruder. The cells controlling this phase, which is called humoral immunity, then select appropriate defenders from an array of other types, each programmed for a certain function, such as digesting bacteria, clearing away cellular debris, or neutralizing poisons. Electromagnetic energy isn't consciously perceived, however, it tricks the immune system into fighting a shadow. Thus, we can predict that just like a fire company answering a false alarm, the body will be less able to fight a real fire. The experiments bear out this supposition. Impaired immune response has been found at many frequencies. Several groups of Soviet researchers have found a decline in the efficiency of white blood cells in rats and guinea pigs after the animals have been exposed to radio waves and microwaves. Most of these experimenters checked for immune system disruption only to power densities of about 500 microwatts, 1/20th of the normal American safety standard. Multiple dangers from higher levels are already considered proven in the Soviet Union. As predicted, however, the most dramatic reported effect on immune response has been produced by Elfield's. During his systematic study of 200 Gauss 50 Hz magnetic fields, Yuri N. Udinstev found that this concentration of bacteria needed to kill mice in such an environment was only 1/5 the needed without the field. When considering resistance to illness, we must also account for the effect of electromagnetic energy on the disease itself, a factor that has so far been all but ignored. Virtually the only evidence to date is a disturbing piece of work by Yu in Achkasova and her colleagues at the Crimean Medical Institute in Simferopol. In 1978, they reported that the results of exposing 13 standards of strains of bacteria, including anthrax, typhus, pneumonia, and staphylococcus, to electric and magnetic fields. After accounting for magnetic storms, ionospheric flux, passage of interplanetary magnetic field boundaries, and other variables, they found clear evidence that an electric field only slightly stronger than the Earth's background stimulated growth of all bacteria and increased resistance to antibiotics. The magnetic fields inhibited the growth of germs, but in many cases still enhanced their resistance to antibiotics. Achkasova concentrated on frequencies between 0.1 and 1 Hz, so the survey was far from complete. But perhaps the most important finding was that every field tested had an effect, even after 1 4-hour exposure. In many cases, longer exposure produced permanent changes in bacterial metabolism.